Hi, this is Ned Johnson. Again, thanks for joining me. Allegedly today doing ACT and SAT tricks. So I'm gonna make this a little bit old school and just do this with a pen and paper. The purpose of today is to talk through what we might describe as tricks, right? You know, for decades, people have talked about SAT tricks or ACT tricks as though this is somehow unfair, okay? As though these are somehow kind of secret tools that only certain people get to know, or that only you need to get a book or a tutor or whatever. And the reality is that these tricks are nothing more than using unsophisticated tools to do more sophisticated math problems. That's all that it is. So the things that we're going to run through today will be tools that you might have done if you were in third grade or fourth grade or seventh grade, but doing 10th, 11th, or 12th grade math tricks. And I do all this work with people your age, but also people taking graduate tests to go to business school or take the jury to get a PhD in whatever. And these tricks work the exact same way for them as they do for me, as they will for you. So we're just going to walk through some of these, and you'll probably hear me saying the same thing over and over and over. And the reason I'm going to do that is that I'm trying to, my words, sort of drill into your head a little bit a comfort with, an okayness with using these tools on problems that seem like aren't I supposed to do it the right way? And a lot of times I get students who are like, but that's not real math that you're doing. And I'm like, well, I would really worry about doing real math if I thought, this is unkind, if I thought these were real tests, okay? This is not your calculus class or pre-calc or algebra 2 or geometry. It's this smorgasbord, this grab bag of things that the test makers have thrown all together. And even they would say, it isn't necessarily about just knowing the math. It's about knowing what tool to use and when. Some of you have heard, or some of you may even feel, I'm great at math so long as I know what formula to apply. Well, in some ways, to give the test makers a break, that's kind of the very nature of the reasoning behind the math on the SAT, or the reason behind the math on the ACT is recognizing what kind of problem do I have and what tool do I use. And so my interest for you is for you to know all the real hardcore math. That's super important. That's all the hard work you're already doing in school. But also to sort of round that out with some tools, again, that your real math teacher would have their heads in their hands, being like, seriously? And so I'm just going to give you a quick preview on what we're going to talk about for the next 25 minutes or so. Plugging in numbers, using the answer choices, and the fact that the pictures on the test, the figures on the test are drawn to scale, okay? So we're just going to go through this bit by bit. I'll do a few of each type, and then we're going to mix them up and try to work to figure out which formula should we use, not which formula, we're not doing real math today, which trick, which technique would be used for this or that problem, okay? So here we go. So I'm going to change my order, actually. I'm going to say the first one is back solving, meaning plug and chug. Use the answers, whatever you want to call it. Lots of people have different ways for this. The second one is plugging in numbers. I know I just went from capital to lowercase. I don't know why, but there you have it. Plugging in numbers. And the third one is the fact that pictures or figures, mathematical figures, I can spell, are drawn to scale, meaning that what they look like is what they are, okay? And so we can trust them, at the very least, to double check our math if we need to. Okay, I cannot see the writing. Oh, thank you for saying something. All right, you guys are great. Thank you. So there we go again. Thanks so much for the feedback. I'm used to doing this one-on-one with folks, and I thought I could have both cameras going. So your feedback to me is super helpful. So again, trick number one, back solving, or plugging and chugging, using the answer choices that are there. Number two, plugging in numbers, which will be numbers of our own. And the third is the fact that the pictures are drawn to scale. So let's go at this. So hopefully you guys have a piece of paper nearby, a pen or a pencil, and if you have one, a calculator. If you don't, no big deal. I'll try to do some of the math myself. Here we go. So the first problem I want to look at is this. Okay. If the product of three consecutive odd integers is 1,287, what is the middle number? Now, it's always a pretty good idea to underline or circle kind of keywords because sometimes people goof that up. I'll start with simple things like what's an integer? Now, hopefully you guys all know or remember that an integer is a whole number. I actually had a student in France where the word integer doesn't exist apparently. And we're going through this work and at some point she's like, what the is an integer, which in French apparently is entier, which means entire number, but you know that it's a whole number. So the product, meaning multiplication, of 3 consecutive, meaning in a row, integers is 1,287. Well, I could say that's 1, 3, and 5, but of course, I don't get to choose. It's got to be one of these things that works. 1 times 3 times 5 is 15. That wasn't going to be big enough anyway, Ned. So how am I going to go about this? Well, I'm going to pick one of the numbers here and then see if it works. And if it works, great, I'm done. If it's too big, I go one way. If it's too small, I go the other way. If I were to use the answer choices, what I would do is pick the middle number, okay? If it's too small, I go this way. If it's too big, I go that way. So let's say that the middle number of 3 consecutive odd integers is 1287. So if one number is 15, what would the other ones be? Note that it's not 15, 17, and 19 because that's not the smallest. They're saying if it's the middle number. So I'll move it up a little bit. If it were the middle number, 15, so that would mean 13 and 17. So you guys have a calculator. I already know that this is not the right answer, but I will go through it for those of you who don't have a calculator. 3,315. Too big. So it is not C. Guess what else it's not? D or E. Let's go up. In the interest of saving your valuable time, let's try A because I think that's the right answer. So if 11 is the right answer, again, that's the middle, then the consecutive odd integer below and the consecutive odd integer above, 9 times 11 times, maybe some of you can do that in your head, but mere mortals cannot. So I'm going to do it that way and say, haha, we have a win. Does that make sense? Okay, any questions? So we can see the answer. So I got a quick version of this I want to try from another page. Give me 1 second as I circle through all my work. I think I can find it. Oh, you know what I'm going to do? I'm just going to write it because that's what I'm going to do. So let's say we have a triangle. We'll make it an SAT with this one. Only 4 answer choices this time. 30, 60, 90, 120. Call that A, call that B, call that C. Hope you all can see that. If A plus B equals C, which of following equals C? Great question. Thanks for asking. So let's again pick with one of the middle numbers. Let's say that it's 60. Okay? If C is 60, then I need to know A plus B. Now you might be asking, how the heck do I know what A and B is? They're 2 unknowns, they're 2 variables. It could be anything. Well, it's an excellent point, but it can be almost anything. Meaning, we know from what the problem says that A plus B must add up to 60. Okay, what's your favorite number? Number 2. I played number 2 as my jersey number in soccer. I was really good at left bench, which means the other number would have to be 58. Awesome, the improbable 2, 58, and 60-degree triangle. Now, as many of you already know, if I add those up, 2 plus 58 is 60 because that's where we started, and 60 plus 60 equals 120. That's great. You're like, woohoo, except a triangle, which I hope you all know, has to have 180 degrees in it. So C, sadly, cannot be 60. Probably can't be 30 either. That would go in the wrong direction. I think you might be on to me. We know that that's going to be 90, or at least we think it's going to be 90. And let's check this again. So 90, A and B, we can make it 45 and 45. We can make it 40 and 50, whatever happy numbers you like. But 40 and 50 make 90, and 90 makes 180. So C simply has to be 90 degrees. Now I know that there are more mathematical ways to go about this, and I'm not truly interested in doing the mathematical version now. If you're desperate to know how to actually do this problem mathematically, and I'm convinced that there's a way to do it, I'm happy to share, just throw it up there in the chat. But the real purpose, again, of doing this work today is to not improve what I suspect are already really good math skills, algebra skills that I'm confident that you have, but really to give you a whole nother set of tools that you can put in your toolbox when you go and take the test. Now, one of the reasons that this is important, I'm making a note to myself, one of the reasons this is important is, oh, I made a mess of that. That's too bad. Is this. Stress makes people not think as well as they might otherwise be able to think. And these tests tend to make people a little nervous. Who's a little anxious taking the SAT? I actually have a book I wrote 10 years ago, 12 years ago about taking the SAT. And I'd done all this work working with students. We'll talk about this test anxiety in a couple of weeks. But they would report, they come back that the test was so much harder than what they did for practice. And even when I sit with kids, they'll say, why is it so easy when I'm here? And it's like, well, probably when you and I are sitting here, we're just talking about whatever we're talking about, and then we're doing a few math problems. You're not as stressed. And what happens is when you're not as stressed, you think better, you don't make those little dopey errors, but you're also a lot more creative in how you answer things. And what I'm really interested in addition to having you have tools, is to have you be able to apply those in a way that's creative. Because you know, a lot of times the first time you try a math problem, it doesn't quite work. And then you go, well, that didn't work. Let me try this, let me try this, let me try this. And the purpose of some of these tools is to get you from the get-go to be thinking, in different ways. The concept in educational psychology is called perceptual narrowing, which basically just means tunnel vision. This is all you can see, and this is all you can think, and you got no other way to do this. I have a college roommate, wonderful guy. He was a soccer player, and he was a really, really good athlete, as with his girlfriend. So we were in this co-ed soccer league, and these two were great. And I'm, as I mentioned, playing number 2 at the end of the left bench, not so much. I am relatively athletic. I'm fast, but I would get the ball and not know what to do with it. I can remember this game we got off, and he'd scream, "Why did you pass that ball to me?" And I'm like, "Dude, I didn't see you." He was like, "How could you not see me? I was right there." Well, under pressure, playing people who were much better at soccer than I was this. I could see my ball and my feet and their feet, but nothing else. I didn't have enough bandwidth to go, oh, there's Don. And I could have passed it to him and he would have scored a goal because he's good and I'm not. And so when we get to these tests, a terrible place to be is, this is how I'm supposed to do it, but that doesn't work. What do I do? And not only does that blow up that problem, but blows up a whole bunch of other problems that come after, because you just feel so angsty about it, so anxious. And so the purpose of these tools is has a couple goals. One, if you can do the work with fewer steps, that's great. If you can do it with less hard thinking, that's great. If you can save time, that's great. But also simply the idea of approaching this with not how should I do this, but how can I do this? Knowing that there's more than one way to go about this kind of unclenches your brain and you just think better and more creatively. Okay, so let me slide on. That was 2 problems of doing of back solving. So now I'm going to go to number 2 on our list. Where is number 2 on our list? That's right, my favorite thing in the world, plugging in numbers. I'm going to try to make them all capital because it's really messy now. Plugging in numbers, my favorite thing in the world. Now the problem that I was going to do, I just made a mess of, so I'm just going to write it out by hand. So if 8 to the x plus 8 to the x plus 8 to the x equals q, find q in terms of x. So you guys can write that down. You can start playing with it. I'm going to write up some answer choices here. So E, I get a lot of E's. I got an A, I got a C, we're covering all of the answer choices. Okay, so I'm going to throw at you what I think most people do. What if you got the right answer? You should be super proud. I'm pretty impressed, honest to gosh. Here's the deal. What most people think of this problem is that you would add these bases and get 32 to the x, okay? Or they will get, a lot of people get 8 to the 4x. Now, it would be 8 to the 4x if we had multiplied these. Because we know like 8 squared times 8 cubed becomes 8 to the 5th. So had we had 8 to the x times 8 to the x, then we would have added 1, 2, 3, 4, and gotten those. Okay? 32 to the x seems like a lot of sense because you have 8, 16, 24, 32. That's awesome too, but the rules when it's with exponents is a little bit funkier. So we're going to go through and plug in numbers, and we'll get to the right answer in just a moment, okay? So as a general rule, then two numbers that you don't really want to use are 0 and 1, especially with exponents, because like x squared, x cubed, 1 over x squared, the square root of x all equal the same bloody thing if x is 1. So that's not such a good idea. So let's pretend that x is 2. I hope you can see this. I'm going to move it up ever so slightly. So x equals 2. So that would be 8 squared plus 8 squared plus 8 squared. I'm going to throw one over there, plus 8 squared to make a little room for my q. 8 squared, as you know, is 64 plus 64 plus 64, blah, blah, blah. 4 times 64 is 256. Awesome. Well, what do I do with that, Ned? Aha! The right answer choice will be whichever one also equals 256 in terms of x. And I'm going to go back there for 1 second. You guys have probably seen problems like this before. Find q in terms of x. I don't know about you, but this in terms of x makes me want to punch someone in the face. It just, I don't know, makes it seem confusing. Like, why do they make it so messy? Here's what I do. La, 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 don't need you, because you know what? I already know that there's x's in the answer choice. So thank you very much for trying to confuse me. Now, what are we trying to do? We're trying to say which answer choice equals this. And we said x was 2, we want to label that, and we said q is 256. So the right answer choice is whichever thing equals 256. So for all of y'all playing along, if you've got a calculator, 8 to the 4 to the x, 8 to the 4x, excuse me, would be 8 to the 8. If you put that on your calculator, I know you guys are a step ahead of me already. It's a remarkably big number. Let's see here. Ooh, 16,770,216. Not what I'm looking for. 64 squared, you also know that's too big. 32, that's like 1,028 or I don't know, 24, something too big. Let's take a look at these guys. Now, if you were to put these things on your calculator, I have a piece of advice. Please do not try to do 2 to the power 2 times 2 plus 3. Because if you do it like that, and I know you guys know this, it's going to get it wrong. If you did parentheses, it would be fine. But otherwise, the calculator will do this, which becomes 2 to the 4th, which is 16, and then add 3, and that won't work. And the same answer choice for E, neither of those would work. So what do I mean? We know that x is 2. I am going to put this thing in my calculator, but I'm going to do this. I'm going to say 2 times 2 is 4, and I know that. That's not beyond my math. Plus 3 is 7, and I know that. And then I can put that in my calculator, and I'll jump down here for 1 second. 3 times 2 is 6, plus 2 is 8. So I'm going to put 2 to the 7th on my calculator and 2 to the 8th on my calculator and find that, lo and behold, it's that one, which for most people, except for Colin, you rock, is like the last choice that most people want to choose. And this is actually from a test. It was one of the very last problems on the test. It's considered really hard because it's a little complicated. It works against what we want it to do. But by plugging in numbers, you can go, I'm not doing all that algebra. Screw the exponents. And just plug in numbers and walk your way through it. Does that kind of make sense? Okay, so I'm going to do a few of those before we then switch over and do the pictures being drawn to scale. If you have questions on that, if you want, does anyone want to have the real math on that? Anyone curious about that? Well, I'm going to humor myself. I'm waiting for someone to respond, and I'm just going to give you the real math anyway. Yes, thank you for answering me, Sophia. So here's the deal. This is really funky, and the reason I'm showing this, I don't want you to do it this way. The reason I really want to show this to you is to make the case for how this problem is actually kind of complicated algebraically, and why plugging the numbers the way we just did can actually be a lovely and an easier way to do this. So here's the thing, 8 to the 4x, excuse me, 8 to the x 4 times would technically be this, 4 8 to the x, or 4 times 8 to the x, which would have led a lot of people to get 32 to x as someone did on the previous page. Oops, sorry, there we go, 4 times 8 to the x, a lot of people would have chosen that, but again, that, as we showed, was not the right answer. So if I want to do anything with exponents, I really have to have the same base. Okay, so what I'm going to do is change 4 into 2 squared and 8 into 2 cubed. Okay, I'm going to ignore that for just a moment. As you probably know, just a quick review, when we raise an exponent to another exponent, those guys multiply, right? Like 2 cubed squared would be 2 cubed times 2 cubed, so that would be 2 to the 6th. So here, these guys do the same thing. They multiply. That becomes 2 to the 3x. Then 2 squared times 2 to the 3x, those guys add, just like x squared times x to the 4th is x to the 6th because it's the total of 6 x's. These guys add, or to change the order like we had on the other answer choice, 2 to the 3x plus 2. So there's always a real proper math way to go about that. But I'm really interested in having you be able to take a shortcut, right? If there are a handful of problems that you could get that you otherwise would struggle to get, awesome news. But also, if there are a handful of problems that you could get right mathematically, but you can do this and use 40% the energy, so you save that time for some problems that really do stink and demand a whole lot of your time and energy and focus and hard thinking. I would like to have some of these questions be a lighter lift, so you have more energy for those ones at the end where you really just have to kind of struggle through it. Is that cool? All right, I'm going to do a couple more of those guys. Another note to myself. Hold on, where was it? Good. So this was what I saw the problem that I had before that I just wrote out, but I kind of made a mess of it. So you're probably like, "That's thank you for rewriting it." So that was the one we just did, right? When we ended up with 2 to the, in this case, 3b, we did 3x. Now, the principal problems that wave their hands to say, hey, plug in numbers here, are problems like this or like this that have letters in the answer choices, okay? And the principal problems that allow you to plug and chug or back solve were ones that were numerical, or the problem we did with the A, B, and C, where it was just numbers or was just numbers. So those are where we tend to use the answer choices or back solve, okay? Over here, where there are letters in the answer choices or variables, if we want to be more mathematical, are the principal places where we plug in numbers. But there are also problems where we can plug in numbers that don't at first seem obvious. And here's a good example. Let you read number 4 for 1 second, and we'll walk through this together. Okay, so we have a triangle. That's exciting. We have another triangle. That's exciting. The base of a triangle is decreased by 20%. Well, I don't know about you. Most people don't love fractions, don't love percentages. Most people find arithmetic, particularly if you can use a calculator, a little bit more than some other math. Now, the reality is, because we can plug in numbers on this problem, because there's no set number. I don't actually know what the base is. I actually don't know what the height is. It's completely relative, one in terms of the other, just like we had over here in terms of B on that problem. So what am I going to do? I'm going to plug in numbers. Now, one of the questions I often get from folks is, well, how do I know what number to plug in? Technically, it doesn't matter at all, because if this is something that is mathematically true, that is algebraically true, it must be true for every number that exists. So gosh, my number should work. That being said, I think the question people really asking is, well, what number kind of should I use? What's the best number to use? And generally, numbers that are small, not 0, 1, as I talked about before, but 2 is a really lovely number. However, for problems with percentages, I bet you can think of a better number to use that might make the math easier or cleaner. Anyone have a guess on that? I'll give you like 30 seconds to type. I'm waiting for Colin or Sophie Brugge. Okay, I'm going to answer my own question. The number that tends to make the math easier is either 10 or 100. Okay? Because it's easier to take 20% of 100 than it is 20% of 34 or something like that. Okay? So here's what I'm going to do. I'm going to make the base of the height of that 10 and the base of that 100. I try not to use the exact same number twice, particularly with things that are algebraic. Using the same number twice, using 2, 2, and 2, that tends to goof things up, because what it'll often do is make more than one answer choice work. Not the end of the world, but then you got to do it all over again anyway. So we'll try not to do that. Okay? So I'm going to make my base be 100 and my height be 10. Let's read this carefully. The base is decreased by 20%. Hopefully you know this. I'm not going to go through lots of percents now, but 20% of 100 is 20. So it's decreased by 20%. A lot of times people just write 20. That's not right. It was decreased by 20, meaning take away 20. Oh, right. I knew that, Ned. So we'll make that 80. Then the height is increased by 50%. Again, it doesn't go to 5. 50% of 10 is 5, so it's going to go up by 50%, so that's going to go to 15. Okay, is that cool? If you have a question, raise your hand, pop it into the Q&A in the chat. Otherwise, we started with a base of 100. We've now dropped that to 80. We started with a height of 10. We've gone up by 50% to 15. Okay, almost there. How do we find the area? 1/2 base times height. So for the little guy, 1/2 of 100 times 10, 1/2 of 1,000 is 500 to the one on the right. 1/2 of 80 times 15. 80 times 15 is 1,200. You guys have a calculator, I hope. 1/2 of that is 600. So what is the ratio of the new area, 600, to the old area, 500? Well, 600 to 500, cross out a couple zeros, is 6 to 5, or 600 to 500, cross out a couple zeros, 6 to 5, and there we are. Okay? So we've covered back solving, plug-in, or using the answer choices, right? Plugging them in. We've covered plugging in numbers. I'm going to show a couple problems where the pictures are drawn to scale. Okay, and then we're going to go back and forth and kind of do a mix of this, because I want you guys to have experience going from one to the next to the next. If we do 20 of one thing, not as useful as if we do kind of mix things up. So give me 1 second, flip through my pile of tricks here. Oh, that's a good one. We'll come back to that. Come back to that. That one. Systems and equations. We'll do that another day. Okay. So, that is a right. Give me 1 moment. I'm going to yell at somebody. Okay, great. Oh, I found it. I thought someone made a mistake. It looks like someone's made a mistake, and you're going to love this. All right. So here's the deal. The pictures on the test always say they're drawn to scale. The ACT language, let me find a test and show it to you. Just in case you think I'm not making this up, I have to let you just go a little further away. Okay. If you take a practice test from the good people at College Board who make the SAT, this is on the beginning. Just a quick note for you. On the SAT, if you don't remember this, they give you all the geometry formulas, which is really great for you guys, because a lot of you, particularly if you're doing advanced math, geometry is kind of in the rear view mirror, and you're like, man, I can't remember that stuff. So just quick reminder, public service announcement that the formulas are right there at the beginning, which is super, super, super useful, okay? And then this is what I'm talking about here. Figures provided in this test, this is the SAT, are drawn to scale unless otherwise indicated. So that means you can trust it. You can trust the test makers, believe it or not. You can trust the picture. You can trust what it looks like. You can trust your own logic and common sense. If, however, it says not drawn to scale, don't trust it at all. Try to redraw it to scale, because if it's not drawn to scale, the test makers have made it as wildly inaccurate as possible. So the problem I did before with a triangle, whatever, the way it was originally drawn, it was like C was like that when we did that math and found that C had to be 90 degrees. So if it's not to scale, don't trust it at all, okay? ACT language, let me find you an ACT math. The very similar language, hold on, what to do. I'll find it. Right here out of the official ACT book, a really good resource, by the way, if you're looking for more practice. I like that book a lot. College Board, of course, has all those practice tests over Khan Academy. And where are we? Illustrative or illustrative figures are not necessarily drawn to scale. So that makes you go, well, that's great, Ned. You told me it is, and they say it's not. I have yet to see a problem on the ACT that was not drawn to scale on the math. I think they take great care to make the pictures really drawn to scale. But I think they're sort of like legal disclaimers covering themselves a little bit in case they ever make a mistake. But ACT people, in my view, pretty good people. You may not like the test, but they're pretty reliable, they're pretty dependable, and their pictures are drawn to scale. Okay, that's the end of the intro to that. Let's go look at some problems. Where did I put it? I've already lost it, guys. Don't panic. Oh, I found it. Okay, here we go. Okay, first of all, not a hard geometry problem. I know that. I know that. Not the point. Not the point. Not a hard geometry problem. I know you guys can do that, but that's not the point. So the question here is, what is the length of X? And I panicked for a moment because here's the deal. I'm trying to figure out what X looks like. The two angles that most people should always be able to eyeball are 180 degrees and 90 degrees, and maybe, whoops, maybe 45 degrees, maybe half of 90, you know that that's 45 degrees. So here's what I did. I took my little piece of my, like, edge of your answer sheet or whatever test, other paper on your test, and you can sit there and go, well, that's bigger than 90, right? So it's definitely not this, this, or this. I'm like, where's my answer? Well, somebody at the printing shop made a mistake and they hid the answer over there. That's the only thing it can be, because it's the only one that's bigger than 90 degrees. I hope we agree, right? Now, the real math, as you said, is not so hard. This would have been 30. These guys make a straight line, so that would have been 50, so 30 and 50, and like we talked before, 180 degrees in a triangle, so that's 100. And again, I know, not a hard problem, but the point of is to sort of practice this as a tool on problems that maybe aren't so hard, so we have it on a problem that is kind of hard. So let me give you, again, a slightly more sophisticated geometry problem. So this guy right here. Now, again, some of you may be totally brushed up on algebra. Some of you may be really rusty and be like, man, I don't know. Can we copy down the notes after this meeting? You can copy down wherever you want. Yeah, a quick reminder. So Melody, thanks for asking while you guys look at this problem. These are all recorded. And we will, and so these are all available on the website. You can follow me on at Ned Johnson if you're a Twitter person, or at Prep Matters. You can come to our website. All of these things will be uploaded within a few days and back online. So if there's something you want to look at again, and we also have a whole worksheet, more practice, much like last week we did punctuation. Have a worksheet. I think they're pretty much all back solving and plugging in numbers. My fabulous colleague Daniela whipped these up for me, and probably about 30 problems over there for you for practice. But yes, these are for both the SAT and for the ACT, for whoever asked anonymously. Okay, so back to here. Now, I'll show you the real math, but I'm most interested in the fact that the pictures are drawn to scale. So we talked about, y'all know what 180 degrees looks like, you know what 90 degrees look like. By looking at this, I'm going to sort of sketch this in and say, to me, that looks like that's about 90 degrees. So the answer choice that I'm most confident it is not is 100, because it is not more than 90 degrees. I'm also pretty confident that it's not 90, because it just doesn't look that way, right? 45 for me kind of goes like that. So I'm thinking that's kind of like 45, maybe like that. So I'm thinking it's not less than 45. If I had to guess between 60 and 80 and I had 20 bucks on it, I would guess that. If I had my life on the line, I would not guess either of them, because I'm not going to do that. But I feel pretty confident, particularly if I'm in a hurry, that looks like 80, which it is. And let me show you why this is important. Even if you love geometry and you're going to do this the math way because you're a math person, that's who you are. I'm going to put back in there that was X. There's a really common math there that tons of people make, and I'm going to show it to you. Now, you might have made this mistake yourself as you went through it. But here's the deal. In a parallelogram, the adjacent sides, the adjacent angles are supplementary. They add to 180 degrees. So that means that 2x minus 60 and x plus 2x minus 60 equals 180 degrees, okay? So 3x, and what people do is they come over here so that 3x equals 120 and x is 40. And I did that really fast, and some of you are already on to me, but I made a mistake on purpose. Because what people do is take away 60 to the other side. Well, the problem is we don't take away 60 by getting over there to get it to the other side, because it's x plus 2x minus 60. To move it to the other side, I have to add 60. And of course, make that 240, and then x is my 80. Easy mistake to make, really easy mistake to make. I've been doing test prep for a million years. That's why I have no hair. I'm actually 87, as I told you last week. People make that over and over and over and over. And it's just a little kind of dopey error that you can make, that I can make, that everybody makes once in a while. And I love this idea of the pictures are drawn to scale, even if you want to do the real math on there. So you can just double check yourself, like, oh, that doesn't look right. Let me check. Oh, let me look at my math one more time. Does that make sense? Okay. So let's run through a few of my favorite problems. Let me look. I got lots of math to share with you guys. If you have other questions while I'm doing this, throw them at me. But otherwise, I'm going to pick and choose, mostly doing plugging in numbers and using the answer choices. Okay. So let's do this, and this is really great. Let's just start with number 10. You all can do number 10. As soon as you have an answer, just type the answer to me in the chat, and then we'll go at it. And hopefully a bunch of you will make the mistake that I hope you'll make. And we got an answer for number 10. They make everybody shy. Okay, we have a K. We have an H. All right. So here's the deal. I want to plug in numbers again. Keeping in mind, funny, I had a student the other day, like, okay, 2 and 3 and 1. You cannot choose things that are not mathematically true. 1 is not bigger than 3, greater than 2, so you can't do that. What, of course, you figure out is there are no integers, so you have to use fractions. Whoops, that doesn't work because a third is not bigger than a half. So a third and a half. Okay. And most people end up, a lot of people, initially choose one of these answers at the top, which is wrong. 1/2 squared, right? 1/2 squared would be 1/4. 1/3 squared would be 1/9. This would be 1/6. This would be 1/3, and this would be 1/2. So of course, that is the right answer. Okay? So let me try a slightly harder version. Let's have you guys do both 11 and 12. 11's a little irritating, 12's a little bit complicated. Actually, we can walk through them. Let me give you guys like 5 minutes, and you can work through all 4 of these, and then I'll just walk through them one by one with you, if that's cool. Okay, so let's give it a try. Now, this is probably the most irritating problem that we've done so far. From my perspective, to set up formulas is a little bit irritating. It's messy even by using the answer choices. And one thing, sorry, thank you for letting me know, Sophia. Blocking things for numbers 3 and 4, sorry about that. And trying to make it taller to get all 4 of these in here. Okay, so number 11, from my perspective, is a pain no matter how we do this. And an important point I want to make, whether the SAT or the ACT, the problems generally go easy to hard, as you know, and the problems are all worth the same, as you know. So importantly, if we get the same value from every single problem, we don't want to spend too much for any one problem, meaning that unless you're gunning for a perfect score, if you're comfortable with something slightly less than that, then oftentimes we do better by doing fewer questions more slowly than doing more questions too quickly. Principally because I never want to have anyone miss a problem that they know how to do because they're in too big of a hurry. That's just the worst. And so in so much of the way that people take tests is based on what they are used to doing in school. And in school, leaving things unanswered is like a terrible idea. But on the SAT and the ACT, it's not. Meaning that if there are 20 questions I really feel comfortable with and there are 4 that I don't, all of that, I wouldn't want to rush through all those problems and goof up easy ones in trying to get to hard ones at the end, right? So if you look at this problem and go, oh, good grief, I have no idea. What do you do? Oh, I think I sense a G. And you pick an answer and you just move on to the next question. Does that make sense? All right, that having been said, let me walk through what this looks like back solving. So again, I'm going to pick a middle number and then I'll go up or go down. So that would be how much money Barney originally had. So Barney had 28. Okay, Fred originally had 2 more than 2/3 the amount that Barney had. Well, here's the deal, 2/3 of 28, that doesn't even work. Okay, meaning that we get a hideous decimal, repeating decimal. So that's not likely going to fly too well from the get-go because it's not going to balance out. So I'm going to go up and try 30. Okay, Fred originally had 2 more than 2/3 of Barney. Okay, well, 1/3 of Barney is 10, so 2/3 of Barney would be 20. Fantastic. So Barney has 20. But he has 2 more. All right, let's change that. He has 2 more. So Fred, 22, 2 more than 2/3 of 30. That looks right to me. Then, after Barney gave $5 to Fred, work to do, he goes up to 27. He goes down to 25. They had the same amount of money. Nope, but close. Whoops, sorry, that's supposed to be 25, my mistake. That's 27, close. So let's go up to 36. Barney has 36. A third of 36 is 12, so 2/3 of 36 is 24. And Fred has 2 more than 2/3, 2 more than 24. Fred gives $5 that way, plus 5, loses $5. Aha, we have our right answer. All right, moving on to number 12. The question with number 12, we talked about on the other page, what's a good number? What the good number is whatever makes the math easy for us, right? So how am I going to do this? I'm going to plug in numbers. The key for this, because I have y in both places, I'm most likely to have the math work out cleanly, meaning not ugly decimals, if I can help it, by picking a number for y. So let's pick a number for y. Let's say y is 2. I keep liking 2, even though it didn't get me off the bench. So y is number 2. So y is 2. So then x would be 4 times 2 squared. Importantly, just a review of exponents, we're not squaring the whole thing. It's only the 2 that's squared. So 2 squared is 4 times 4 is 16. So x would be 16. And then z, y is again 2. 2 times 2, 4 minus 6 would be minus 2. Slightly ugly number, but you can handle it. Which of the following expresses x? Again, get rid of this. We don't need it. It makes it seem harder. Which of the following expresses x? X is 16. So I like to circle the answer that I'm looking for and say which of these things equals 16. When, what do we say z is? We said z is -2. Okay, f, -2 plus 8. That's not 16. -2 squared, again, we're squaring just that part. 4 times 2, 8. 8 plus 17, 8 plus 9, 17, not that. -2 plus 8 is 6. 6 squared, 36. Ends the right way, but not what we're looking for. -2 plus 6, 4. 4 squared, 16. I think we have a winner. We can check all the answers. This would be -2, 4. 8 plus -6. 2 plus 9 would be 11. It's not that. It's a solid idea to check all the answers because sometimes you can get more than one answer that seems to work, and then that causes a problem. Okay, last 2 problems, and then I'll send you guys out the door. So sorry for blocking the cord. Let's do these 2, and then we'll sum up, and we'll send you out the door with homework. So this looks a lot like that first problem we did when we had the sum with the product of 3 consecutive odd integers. Here we have the sum of 3 consecutive even integers. So I'm going to pick 3 consecutive even integers. 2 plus 4 plus 6. 6 plus 6, 12, aha. So that means W equals 12. Always a good idea to label things. In terms of, I hate that, what is the sum of the next 3 consecutive, and this is where reading is really important, consecutive odd integers that follow the greatest of the 3 even. So that would be 7, 9, and 11, because the greatest even is 6. The ones that follow after it, 7, 9, 11, adds up to 27. The right answer choice will be whichever thing equals 27. And that will be, let's see, 3 times 13, 39, that's not it. 3 times 12, 36 plus 1, 37. 12 plus 9, 21. 12 plus 7, 15, 27. Not that one either. Okay? And then the last problem, and then I have some advice for y'all. So each side of a square has a length of s. When all the lengths are doubled, the area of the square is increased by 108. By 108, not 208, but by 108. So let's start with here. So 5, 5. If we double it, goes to 10 and 10. Does the area increase by 108? Well, area, base times height, 25. Area here, base times height, 100. Does it go up by 108? No, it goes up by 75. Do we think we need a bigger number or a smaller number? I'm thinking bigger, but let's find out. 6, 6. If I double that, 12, 12. Area there, 36. Area there, 144. 144 minus 36 is, as you guessed it, 108. So that's the right answer. So a last quick word on this. Some of you might be following my colleague, Aaron Golumsky, Dr. Aaron Golumsky, who's teaching AP Chem. Absolutely brilliant guy. And he told me this story a few years ago. He was working with this kid who went to an independent school here, a private school here in DC. Really, great student, a little antsy about this test. He'd done a whole bunch of work with another tutor. And so this guy rolls in. And so some really complicated version, actually, I'll show you my favorite problem. You guys can work on this while I tell you the story. This is for, I know a couple of you guys are hardcore math folks. This is my favorite one. I'll tell you this story. Okay. So Aaron's working with this guy, and they get some complicated problems, sort of like this one. And the guy's having a hard time because it's a hard problem. And so Aaron looks at him and he says, did your other tutor ever talk to you about maybe, like plugging a number there? And the kid's face falls. And Aaron says, what? And he says, well, my other tutor told me that plugging in numbers is for losers who can't do real math. And Aaron said, using the same line that I just said, that, it would be fine if we did real math, if this were a real math test. Because in school, your teacher doesn't care that you get the right answer. She cares how you got the right answer, because the purpose of a math class is to teach you math knowledge, but also math skills or math tools. So you can apply that same skill in lots of different problems going forward. But the SAT doesn't care how you do it. The ACT does not care how you do it. You get no partial credit. And so whatever math tool, whatever approach is the easiest for you is the right one for you to use there. So I'm going to go through this problem. Colin again is showing me. Colin, are you a student or are you a tutor? You're pretty good at this stuff. Fun to watch. This again looks really gentle algebraically, but it's actually a little bit complicated. So do you guys want the math? Do you want the real math first or the plugging in numbers first? Waiting for opinion. Real math or plugging in numbers? All right, I'll do the real math first. Aha, thank you, Sophie, the real math. So here's the deal. 2 to the x plus 1 means 2 to the x times 2 to the 1. Okay, we agreed that before because we did those exponents, right? Those guys add. So I can add those and make that 2 to the 5th, but I can also take it apart and make it 2 to the x times 2 to the 1. Okay? Here's the kind of fun part. 4 to the x could also be said to be 2 squared to the x, like we said, because 4 is 2 squared. These guys, as we did on the other page, multiply 2 to the 2x. So here's the kind of fun part. 2 to the 2x, a couple ways to go about this, but you could also say that that's 2 to the x times 2, because same thing, right? And then, just like we pulled this apart, I can change this and make that 2 to the x quantity squared. Well, if 2 to the x quantity squared, we said that 2 to the x equaled, remember back up here, where was I? Oh, right. If 2 to the x plus 1, sorry, I skipped one step. If 2 to the x plus 1 equals q, and 2 to the x times 2 to the 1 equals q, then I can say that 2 to the x is q over 2. So if I go back over here, if 2 to the x equals q, then 2 to the x squared would be q over 2 squared, which of course is q squared over 4, and that's our right answer. Is that cool? Now, if I did this plugging in numbers, which is my favorite way, that would be 2. So 2 cubed is 8, so q would be 8. I'm looking for 4 to the x. And we said that's 4 squared, so I'm looking for 16. I don't like that ever. I'm looking for 16 when q is 8. 8 squared, 64 divided by 4 is, of course, 16. And there again is our right answer. So the tools, again, that I want you guys to think about, not that you have to use them every time, but just so you can avoid perceptual narrowing, you don't get tunnel vision, you don't feel stuck if the real math doesn't work. But also, even if you can do the real math, or ideally you can do the real math, if you use one of these steps and it takes you 30 seconds rather than a minute and a half, you've just earned yourself a minute to use on some really difficult problem where, gosh, you'd really write that extra time. So again, the 3 things that I'll encourage are back solving, meaning using the answer choices, plug in numbers, and then last, that the pictures are drawn to scale. So I think we'll send this out in an email at the very least. It's over on the website right now. A whole bunch of practice problems. Thank you, my colleague Daniela, for helping me out with that. And I look forward to seeing you guys next week. Again, as always, if you have specific questions, actually, if there are things you'd like us to cover that doesn't look like it's part of the lineup, feel free to shoot me an email. Feel free to tweet me on Twitter or respond to the email that popped up. Any of the ways that you can reach us. Our interest is always in helping you all. If you have questions, if you have suggestions, if you have feedback, I'm always happy to have it. I hope you guys are staying safe and not driving your parents crazy, or more importantly, having them drive you crazy, as we all try to get through this kind of interesting time of life. Thanks for joining me, guys, and I look forward to seeing you next week. Bye-bye.